Hello my fellow developers and welcome back to the Postgres as a vector database series. Today we are exploring the Microsoft Azure AI extension. With that extension we can generate embeddings straight from our Postgres database instances. And apart from the embeddings generation capabilities, Azure AI lets you do sentiment analysis, language detection, and perform other AI-specific tasks. So let's not waste a minute and explore the extension in action. To get started with the Microsoft Azure AI extension, you need to complete two prerequisite tasks. Number one, deploy an instance of the Azure AI service and create the embedding model. I'm going to use the text embedding ADA002 version of that model. And task number two, you need to deploy an instance of the Azure database for PostgreSQL. Once that instance is deployed, go to the Server Parameters tab and there find the Azure Extensions property and allow to use the Azure AI extension and also the vector extension. The vector extension is necessary because we are going to improve our existing application that uses the pgvector extension of Postgres. Once those services are ready, use your favorite SQL tool to connect to the Postgres instance and start experimenting with the Azure AI extension. Alright, I'm connected to my Postgres instance. You remember that Azure Extensions property that lists allowed extensions? You can also see the same extensions that we enabled on the interface by executing the following SQL requests. Even though those extensions are allowed, you need to create them for this specific instance. Create extension, if not exists, vector, and let's create Azure AI extension. Create it and double check that those extensions are in fact available in our Postgres instance. Select from PG extension. Let's make it bigger and you can see that we do in fact have these extensions available for our little experiments. And last one, configuration step left, my friend. We need to tell Postgres how to connect to our Azure AI instance so that it can generate embeddings for us. To do that, specify these two configuration parameters on the Postgres end. The first one, Azure OpenAI endpoint. Postgres will use this setting to open a connection with your Azure OpenAI instance. And the second one, Azure OpenAI subscription key. Postgres will use this key to authenticate with your OpenAI instance. Alright, the Azure AI extension is fully configured and ready for our requests. How about we generate the very first embedding using Postgres? Let's do it. Select Azure OpenAI create embeddings function, and then you need to pass two parameters to this function. The first parameter is the name of your embedding model that we created previously using Azure OpenAI Studio, and the user prompt, the text that you want to translate to a vectorized representation. How about this one? Build AI apps with Postgres. We are ready. Let's generate the embedding. Excellent. This was generated using the Azure OpenAI and Postgres. Also, in the beginning, I mentioned that the Azure AI extension can be used for other AI-specific tasks. How about this one? For instance, you want to measure the sentiment of the text that is provided by the users, and for that you can use the Azure Cognitive Service and its Analyze Sentiment function. Right now, I don't have this service set up on my end. If you wish, just drop me a note in the comments and I will plan the video for the future. But today I want us to master the embeddings generation capabilities. For that, let's simplify the logic of one of our existing applications. Those of you who watched the previous episodes from the Postgres as a vector database series already remember this application. If you missed those videos, just find a playlist on my YouTube channel and see how we built this application from scratch. What the application is doing is it takes a user prompt and suggests different Airbnb listings for those traveling to San Francisco. For instance, this time we are traveling to the city and we want to stay near the Golden Gate Bridge. So we click the search button and we get a list of recommendations. And those recommendations are retrieved from the Postgres instance that is running right now in Azure. That Postgres instance that comes with the Azure AI extension. In the description to this video, you will find a reference to the following GitHub repository. That's that application that we built previously, but right now it works directly with the Azure OpenAI service and with Azure database for PostgreSQL. I already skipped all the mundane tasks. I created OpenAI, I deployed Postgres in Azure, I preloaded the dataset and all the embeddings. If you wish to reproduce my steps, just go ahead, clone this repository and get your environment ready, because right now I want to see how we can simplify the source code by using the embeddings generation capabilities of the Azure AI extension. Let's open the source code that generates those Airbnb recommendations based on the provided user prompt. Here is our search places method. We are using the Azure OpenAI SDK here. That's the OpenAI client that was created for Azure. Then what we do, we take the user prompt and we use this Azure OpenAI client to generate embedding for this user prompt. And once this embedding is generated, we send a request to our Postgres database instance to find the most relevant Airbnb listings. That's the SQL request that does this. Now, what I want to do, I want to get rid of this call. I no longer want to call the Azure OpenAI service directly. So let me remove the first part of this logic, and I want the database to generate this embedding for the user prompt. We need to update this SQL request. Let's begin. I'm going to use the common table expression capabilities of Postgres. We will generate the following temporary table, and that table will keep an embedding that corresponds to the provided user prompt. First, let's make a call to the Azure AI extension, Azure OpenAI, and we need to execute the create embeddings function. If you remember, we need to provide two parameters. The first one is the name of our embedding model. In our case, it was embedding model. And then you need to provide the text that you want to translate to an embedding. In our case, we need to provide the user prompt. So the user prompt is passed here to the search places method. And we just need to update the following list of parameters. Let's pass the prompt here as is. So the create embeddings function of Azure OpenAI generates an array of floating point numbers, and I want to translate this array to the vector data type. For that, one of the options is to do this, select. I am converting the result of this function to the vector data type, and I want to store this result in the column embedding. It looks nice. Next step, we need to update the following select statement. First, in the result, you can see that in addition to the name, description, and price of suggested Airbnb listings, we also provide the similarity, how the following Airbnb description is similar to the user prompt. Here is we need to make a call to our temporary table, select embedding from prompt. Then we need to update similar places. For instance, here is in the where clause, when we are selecting most relevant Airbnb listings, we are calculating the assigned distance between the embedding of Airbnb descriptions and the user prompt. So right now you know that the vector for that user prompt is stored here. We are updating. And finally, we are also ordering by this distance. We need to update it here. Okay. That's it. How about we test these changes? Let's restart our backend. It's ready. Now we need to jump back to our application. Let's just in case refresh this application and execute the same request. Done. The application provided the same Airbnb recommendations for the following user prompt. But only this time we improved the application logic. Instead of making a separate call from the application to the OpenAI, we made this call straight from Postgres. We used the Microsoft Azure OpenAI extension and generated the embedding for the provided user prompt. And then we performed a similarity search within the Postgres instance by finding the most relevant Airbnb listings for that user request. Alright, how do you like this new Azure AI extension, my friend? I think that it makes Postgres even more powerful for generative AI applications. I only hope that this extension will become available for all types of Postgres deployments. With that, Stay tuned for the next videos about Postgres and other databases. Bye bye now, my fellow developer.